So I wanted to start out this screencast. This is week number 9, I guess. This is screencast number 9 for week number 9. And I was first wanting to talk about the paper topic, which was dealing with visualizing electricity and magnetism through simulations, and getting kids to better understand mechanics, I guess, of how magnetism works and electromagnetism through these simulations. And so what our group started looking at was a paper which was here. And what it does is goes through a number of simulations and talks about them from this teal program. And I know we've had some communication regarding whether or not we could access these animations. And it seems like I'm having difficulty doing so, even though I've downloaded a couple of programs to try to make it easier to go ahead and run these simulations. Most of them I can run on that site, but and that is this site here. But the magnetostatics, often many of those I cannot run, and that seems to be the crux of some of the simulations that they talk about in the paper. So that provides a little bit of difficulty. I guess one question I had is that there's this other article here that seems real good, and it talks a little bit more about how students learn with simulations and where the benefits come in, and it comes up. It has a little more background, I guess. So I'm going to propose that this paper maybe is our focus paper for the project, and I'm wondering if that's acceptable. That we don't necessarily have a whole bunch of specific simulations that we can use, but yet still focus on this particular topic and this sort of teal simulation website. There seems to be a lot of good background information that we could really extract and use that relates to this course. So I guess I would hope that the instructors would accept such an option if we can't get all of the simulations on that teal website to run. So anyway, I was just wondering about that. The next topic I kind of wanted to talk about for this screencast was the response by David Weaver. One of the responses, I've read a lot of your responses. Thank you for the feedback. I guess one thing that kind of struck me in modeling in general was how, David, you had said that you don't even bother correcting or accepting students' quantitative solutions without some sort of qualitative explanation, without doing qualitative explanations first. And that's wonderful, because I feel the same way, and I feel that's a huge strength of modeling, is that it does demand conceptual understanding. And plugging in numbers into an equation, that's no problem, but extracting the meaning, and not only that, but extracting how something works to cause a certain numerical result is great in terms of sort of what the teacher sees, but also I would think would be more fulfilling for students. And so actually getting back to this paper, it specifically talks about how the simulations really cause a deeper conceptual understanding for students, and how that can translate into doing a better job when you approach a problem and try to solve it quantitatively. And so that was a great comment. And our district now is going through a whole series of accreditation preparation for becoming recertificated, getting a recertification for accreditation, and we're starting this remediation program and sort of try to espouse a more of a growth mindset, and so it really falls in line well with the modeling curriculum that we're using. So I really appreciate the electricity and magnetism modeling understanding that I'm gaining now, because that's going to be a large part of the curriculum in the future. I am wondering, I guess, if there is, training, specific week-long training or something that you've come across that regarding mechanical waves and light, sound, those kind of things, because that's the one area, the major topic area, that I feel like I'm not. I guess I haven't gone through any kind of modeling coursework regarding those topics. I've done 2 weeks of the mechanics, and then this week this course in the E&M, but not any of the waves, mechanical waves or electromagnetic waves, although that seems like we might cover some of the electromagnetic information, hopefully in this course. I'm not sure if we'll quite get to that. But at least talking about, how electromagnetic waves are formed, and then how they, generate sort of themselves through space would be a wonderful discussion to have sometime in this course. Another thing I really looked at this week, I went through the lab 1, what happens in the wires, and that's a great lab, and it really sort of, I guess, probing the different potential differences in different locations kind of gave me a better feel for what's going on in the wires. You really have to be careful about following the directions carefully. And I guess the way I did this was with vernier equipment, and I used the standard probes that came with the vernier equipment, initially. So it wasn't the voltage probe, the differential voltage probe, but it was just the standard probes that come to measure, electrical conductivity or voltage, I guess. And so that worked well, except it did not seem to do a good job of allowing me to change the sampling rate to 2,000 samples per second. What it did is, it allowed me to change that value, but then when I hit the start, it kind of instantaneously went through and filled in 5 seconds worth of data, or even 15 seconds worth of data. And so obviously that wasn't accurate. And plus there was really no difference in the data. It was just all reading 0 volts as I tried to start that. And it just happened so quickly that there's no way I could have, connected the probes after the run button was initiated. And so I guess, but the lab, I could still make sense of it even without that, change in the sampling rate for the one exercise. And so I'm wondering how really necessary that is to increase the data collection rate. I don't know what you'd see other than, I don't know if you'd see different micro pattern or a different smaller sort of change within that change we saw in the more lower resolution 200 samples per second rate. But anyway, it was interesting to think about how there's actually a potential difference built up initially when you start to discharge, and that's what causes an electric field to be formed. And that's my understanding, that there's no electric field when the capacitor is charged to cause the charge to move from the positive terminal to the negative terminal. Since it can't move across the terminals themselves. And when you connect the circuit, then you actually get electric field so that it causes the charge to go ahead and move at that point once you do have an electric field set up, just because some of those negative electrons from the negative side are transferred over to the positive side. And then that creates a potential difference. And so that seems to be, the understanding that I'm trying to make out of it. Now, it's a little bit of a jump to just use this lab as a way to draw out the understanding of this. It's kind of like you almost have to draw diagrams first and allow the kids to see that before you go ahead and do this lab.